Certainly. Linear algebra is a branch of mathematics that deals with vector spaces and linear transformations between those spaces. It is a fundamental tool in many areas of science, engineering, and computer science. Here are some key concepts and topics in linear algebra. 1. Vectors. Vectors are objects that have both magnitude and direction. They are often represented as columns or rows of numbers. In linear algebra, vectors can be added together and multiplied by scalars, numbers. 2. Vector spaces. A vector space is a collection of vectors that satisfy certain properties. These properties include closure under addition and scalar multiplication, associativity, commutativity, and the existence of an additive identity and additive inverses. 3. Matrices. Matrices are rectangular arrays of numbers. They can be used to represent linear transformations, systems of linear equations, and many other mathematical objects. Matrices have operations such as addition, scalar multiplication, and matrix multiplication. 4. Linear transformations. A linear transformation is a function that preserves vector addition and scalar multiplication. It maps vectors from one vector space to another. Examples of linear transformations include rotations, reflections, and projections. 5. Systems of linear equations. Linear algebra provides tools for solving systems of linear equations. A system of linear equations consists of multiple equations with the same variables. Matrices and vector operations can be used to represent and solve these systems. 6. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors are important concepts in linear algebra. An eigenvector of a linear transformation is a non-zero vector that only changes by a scalar factor when the transformation is applied. The corresponding scalar factor is the eigenvalue. 7. Determinants. The determinant is a scalar value associated with a square matrix. It provides important information about the matrix, such as whether it is invertible and the scaling factor of the linear transformation represented by the matrix. 8. Vector spaces and subspaces. Vector spaces can have subspaces, which are subsets of the vector space that are themselves vector spaces. Subspaces have properties similar to those of the larger vector space. 9. Orthogonality and inner products. Orthogonality is a concept related to perpendicularity in vector spaces. Inner products generalize the dot product and provide a way to measure angles and lengths of vectors. 10. Singular value decomposition. SVD. SVD is a factorization of which can be used for various purposes, which can be used for various purposes such as matrix approximation, data compression, and solving linear systems. These are just some of the fundamental concepts in linear algebra. The subject is vast and has many applications in fields such as physics, computer graphics, data analysis, and machine learning. Exploring these concepts in depth will give you a solid foundation in linear algebra.